This is the podcast review for Earth Science, 7th grade, 3.1, The Water Planet. All right, the very first thing we're going to talk about is water. And water actually exists as three different states, and that is a solid, a liquid, and a gas. As a solid, it's ice, and that's at a very low temperature. Liquid, obviously, it's water. Now, a liquid can also become a gas, which sometimes we call vapor. One of the great things about liquid water is it can fit any container, just like any other liquid can. So it's going to hold its shape in a raindrop, though, or it can merge with other drops to flow downhill, such as in rivers. Water covers most of our Earth, which is why we're called the water planet. It covers Earth. Right? Most of our Earth's surface is ocean. Those oceans include the Atlantic, the Pacific, the Indian, and the Arctic. And they're actually connected all together. And together they actually form one huge ocean, and generally we call that the sea. Now, this global ocean, or sea, actually covers about 71%, or almost 3/4 of our Earth. Let's get that Earth in here. So if you take a look here, right? So 71% of our Earth is water. Well, only 29% of it is land, and that's why we're typically called the blue planet, if you see all this blue. Now, most of this water is actually covering the southern part of the Earth, and it's called the southern hemisphere. Now, water again. Here, we'll go ahead and write water again just for the heck of it. Okay. It is very important to us on Earth. Nothing could actually live on Earth without it. Your body is actually 2/3 water. And water actually makes up most of the blood that's in your body, which carries the nutrients that give you energy and flushes waste away. And then also, many of the organisms here on Earth live in water, and that includes an ocean, lakes, and rivers, which are home to fish, mammals, plants, and other organisms. There are two different types of water. There is fresh water, and there is salt water. Fresh being the one that you drink, the ones that we have in our homes, the ones that we take our showers with, wash our hands with. The other one is salt water, and this is typically found in our oceans. We can actually not survive by drinking salt water. Salt water drinking, if you drink it, it can actually kill you because it'll actually take some of the water out of your body. It causes you to dehydrate. On Earth, there are different amounts of each of these. So approximately 97% of Earth's water is salt water. Only 3% of it is the fresh water that we need to survive. Okay. Of the fresh water, there is 30% that's free-flowing. 70% of it is frozen. Most of that is on ice, land, and in the oceans. All right, as we know, water is a cycle, and there are different parts to that water cycle. And the water cycle is a continuous process. It goes around and around and around. It's never going to stop. It's a cycle. In this cycle, the water is going to change its state from a liquid on land to a vapor in the atmosphere, and again to a liquid that falls down to the surface of our Earth. Now, there's a couple of different means within this, or different ways that these are called. So the first one is evaporation. This is where the water turns into a vapor. This is typically happened or caused by radiation from the sun. So it's causing heat, which causes the water to vaporize or evaporate. Then you're going to get condensation, and this is where it gathers into clouds, and then it's going to become precipitation, where it's going to fall down onto Earth. Now, as we know, there is another form called transpiration. We're not going to deal with that now, but that's where the leaves actually release the water back into the atmosphere as well. All right, if we go back to the picture of our Earth, you'll notice again that so much of our world is water. Well, this is where the majority of our water cycle actually occurs, is out here on our oceans. In fact, approximately 85% of the water that evaporates on our Earth evaporates over the ocean. Now, about 75% of this condenses into cloud droplets, and it's going to fall right back onto that ocean. So actually, the majority of our water cycle occurs over our oceans. Now, as we know, this again is salt water. So this is salt water. But when it evaporates, it leaves that salt behind, and it only takes up the water droplets. But when it evaporates and then it condenses into the air and it falls right back down, it's going to mix with that salt water and it's going to be salt water again, right? So, but while it's up in the air, that is all fresh water. All right, next up we're going to talk about surface water. And obviously this means the water that is on the surface of our Earth. As water falls onto Earth, gravity is going to pull the water downhill. As that water gets pulled downhill, it's going to flow between high points called divides. These are the high points. And areas called drainage basins. So a divide is a ridge or a continuous line of high land from which the water flows in different directions. Okay, so here is the divide that's here in the middle. So you have this line of mountains here. This is the divide, and water is going to fall down in different directions, and it's going to land here in the drainage basins. So a drainage basin, which is also sometimes called a watershed, it's the area on either side of a divide where the water is going to flow down. And when it rains in a drainage basin, the water forms streams and rivers, or it's going to sink into the ground and become groundwater, which we'll talk about later. Now, surface water also collects in ponds and lakes. Right? These are natural areas that are going to collect water as it falls onto Earth. Now, there's a couple of different ways in which a lake can fill, right? So there's the land surface dipping below the level of the underground water. So land dipping below. Also, we can have rainfall or other precipitation. Rivers or lake or streams might flow into a lake. And water can flow away from a lake through a stream as well. So this is going to actually flow away. Now a pond, that is just really a smaller version, a shallower version of a lake. And next part is about lake turnover. So the way lake turnover works is that the temperature in the lake is going to change, and it's going to be different at different levels, and it's going to be different during different seasons. I want you to take a look at this picture here. Okay, so in summer, you're going to see warm water, which is high in oxygen at the top of the lake. And colder water is low in the lake, and you're going to have nutrients at the bottom because they're settling down. However, in the fall, what's going to happen is the nutrients and oxygen are going to move throughout the lake because you're going to have a change in temperature. All right, next up is eutrophication. A big, long word. And what this means is that you're going to get an increase in nutrients in a lake or pond. And this is going to cause an increase in the growth of algae and plants. And remember, this is going to cause a scum type thing to happen on the top of the water. That's going to limit the amount of oxygen that can get into the water, and that's going to mean that you're going to have less water or less oxygen inside for the organisms and fish that require oxygen. They can't survive without it. They're not going to be able to have that, so they're going to die off. This is typically a slow process. However, it can become quite fast when certain things are applied to it, such as pollution, phosphates from our laundry detergents. Those can actually get in there and increase the rate at which eutrophication happens, which is going to cause an aquatic dead zone. Now, most of our fresh water on Earth is frozen, and in fact, 2/3 of our fresh water is locked up in the poles that are at the north and south parts of our Earth. At those areas, you're going to find glaciers. And glaciers are those large blocks of snow and ice that are actually covering the land. There are two different kinds of glaciers. There is a continental glacier, and there is a valley glacier. Icebergs start out as part of a glacier, but then they're going to break off of the shelf of the glacier, and they're going to float away, and that's going to become an iceberg. Now remember, only about 1/8 of the total weight and volume of the iceberg is seen on the surface of the water. So if we take a look at this picture, and let's make it even smaller, about that big, we can see that this, if we were to break this down, this is much, much bigger down below it than it is on top. In fact, it's probably about twice as big as I just drew it, because that's only maybe about 1/4 of the size. So maybe we want to take this and we want to expand it even bigger. And so only that much of it is actually shown on the top of the water compared to everything that's down below. As we know, scientists are concerned about this. They're concerned about the fact that our Earth's climate is changing. It's causing these ice shelves to melt at a record speed. Our ice shelves that used to be much bigger have slowly dwindled in size, and it's becoming happening at a much more rapid rate as time goes by. All right, next up is groundwater, which means the water that is kept underground. So when water falls to Earth, it's going to go different places. It's going to flow along the Earth's surface into rivers or reservoirs. It's going to evaporate and become part of the water cycle again, or it's going to sink down into the soil. Well, what happens is as that water flows down into the soil, that last part, it actually is going to fill the underground spaces, and that's called our underground or our groundwater. Now, there are two particular points to groundwater that are important. There is the permeable layer and the impermeable layer. Now, the permeable layer, this is going to be things like sand, gravel, and those sorts of things. And this is where water can actually flow through it. And then the impermeable layer, this is going to be solid. This is going to be rock. And that is going to actually stop the water. It's not going to be able to go through the surface. So again, as the water is pulled down by gravity from through precipitation and such, it's going to sink down through the permeable layer, and it's going to collect in the bottom of the layer, but it's going to be stopped by that impermeable layer, and it's going to gather there and be a part of the water table. Aquifers, right? These are the part of the water table that lies down beneath the surface. It can be right beneath the topsoil, or it could be all the way down to that bottom impermeable layer. Here's a picture of an aquifer. Remember that an aquifer, this is the underground layer of permeable rock that contains the water. Now, in order for an aquifer to form, there are 3 different things that you need. You need that layer of permeable material. You need a section of impermeable layer. In order to hold the water in place, and you need a source of water that can refill it. Remember, one of the greatest parts about a aquifer is that the permeable layer will actually filter out the water as it flows down through its layers. It's going to use the stones and the sand to filter out bacteria and other living organisms, and it's going to remove the harmful chemicals and minerals that are within that water as well. Now, all this water that is down in our aquifers, it can actually be used in our homes by drilling wells or like freshwater springs. And those freshwater springs, they have the freshest, cleanest tasting water, and that's typically where our bottled water comes from. Now, the water table, it can actually vary from place to place and from season to season, and that's going to depend on how much rain falls, how much water is used, how much goes into the aquifers, how much is being replaced, and that amount of rainfall, the amount of water in the aquifer can also change how the landscape is going to look, because if there's not enough, there's not going to be enough to support the land above it, and you're going to get damage to the environment. And our last item that we're going to talk about is hot springs. Remember, hot springs are where we have water that has gone down into the ground and it's going to reach those lower levels down near the interior of our earth, which has a lot of heat and pressure. And that hot water down there is going to build up and become hot, and it's going to rise to the surface, and that's going to cause a hot spring. Well, that can also cause geysers. In a geyser, you're going to have this pipe where the water has come down through, and it's going to heat underground, and when that pressure becomes so high down below, it's going to shoot the water up that pipe with such force that it's going to burst out the top, providing quite the spectacular show. This often happens at Yellowstone National Park, and people go there all the time to go see them. So this is another form of a hot spring. All right, and that's going to be the end of the podcast review. So as always, good luck and happy studying.